All right, so today we are going to compute with scientific notation, but we are only going to do the adding and subtracting today. Tomorrow we will do the multiply and divide. Can you guess which one's easier? Multiply. Easier. Central question: why don't we make scientific notation standard foreign? Okay, there's a reason we do that. Scientific notation is really, really big or really, really small. Those are annoying to work with. So we are going to actually take any number we have and we are going to make them into, make sure they are scientific notation and solve from there. But here's the thing, with adding and subtracting, that scientific notation does not always stay a true scientific notation. Okay, sometimes they do have to change. All right, so looking at the problems. And I'm just going to jump right into solving. There's not a whole lot of notes. There's just a whole lot of examples. Because you guys got better on just writing them as scientific notation when they were examples. So let's compute. We have things such as that right there. Now the great thing is scientific notation, when you add and subtract them, the steps are going to stay the same. But we cannot just add or subtract the way they are. The reason being that exponent. Exponent goes on top. You cannot just add or subtract since one's 10 to the third and one's 10 to the fourth. Not going to work out for us. So what we have to do is we have to get the exponent to the exact same value. Which exponent is larger? The 4. So what I'm going to do is I'm going to change the smaller one to match the larger one. What that means, we have 4, this one's a 3, right? How do we get from 3 to 4? Add 1. When I add 1 to the exponent, can you guys guess what happens to that decimal? Moves over, left or right? Moves to the left ones. Because you're adding 1. Remember positive exponents? When it's it just pushes our decimal too. Yeah. No, hold on. Wait. I think. This is one of those that I only teach it like once a year and I keep forgetting, so I got to make sure. Yeah, there we go. Okay. Yes.
Like if we were to add more, if we were to add more to the 3, we would move it like 1.
Huh? Yeah, you would move it as many times as you have to add up.
To make that number, the larger number.
Yes. Okay. Any questions on that? And okay, when you add this, I'm going to show you on the side. So this right here, you have 5.45 times 10 to the third, right? To make this into a standard form, what would you do? 1, 2, 3, right? So that's 5,450. But if I moved it 1, 2, 3, 4, it places the decimal in front of the 5, right? You added 1 more loop to it. Does that explain it better? Okay. So this is now 0 and 5, 4, 5 times 10 to the 4th. Is that a true scientific notation? No. And our final answer will not look like this. Plus 3.12 times 10 to the 4th. See our exponents? Are they the same?
Yeah.
You know, on fractions, when we add, what do you actually add? Numerators. What happens to the denominators? What happens to our power of 10? It stays the exact same. That's the whole point of this. Fractions, you have to have a common denominator. Scientific notation, you have to have the same power of 10. That's going to stay. Times 10 to the fourth power. Yes.
So when you did,
Oh, it is while you're talking, but yes.
the 4 is on the left column. If it's on the right, is it just the same?
Yeah, it's the same thing. I don't care which one it is. You're really going to find the smaller one and change it to match the larger. Okay? See these numbers right here? Can anyone have a guess of what we're going to do with that?
Add them.
Add them. 0.455 plus 3.120. What's 5 plus 0? 4 plus 2. 5 plus 1. Bring down your decimal. Nothing plus 3. There's your answer. The other way of doing this would have been make them standard form, which means this one would have gone 1, 2, 3, 4. Then you would have had.
Do you write what's on the side too?
You can. You would have added it up. You would have had to change them both into standard form to add them up to change it back into scientific form. This shortens it just a bit. Okay. You guys ready to try another one?
So whenever we do the answer, we always put times.
It would always be times 10. It's scientific notation. Scientific notation has to have that times 10 to the fourth. Sorry, I'm checking to make sure Joseph is, not Joseph, Gage is going to be able to read it. Okay? Hopefully you can. Okay? Any questions on that? Are you guys ready for another one? Okay. So I got to adjust because I'm moving over a bit. Okay? Next one, you are going to write down 2.78 times 10 to the fifth.
To the what?
Oh. Into the fifth, plus minus this time. This one's going to be a little bit different. Why is that different? Two things are different. Subtracting and its standard form. That's okay. Subtracting does not change anything we're going to do. All that's going to change is this step right here. Instead of add, we're going to subtract. Okay? What do I want you guys to put these in? Not standard form. In scientific notation. Is this in scientific notation?
Yes.
Is this one?
No.
No. So we're going to make it scientific notation. Our decimal is at the very end. We go 1, 2, 3, 4. If I stop right there, is our decimals going to match? Or not our decimals, our exponents going to match?
No.
This is to the fifth. This one's to the what?
Fourth.
To the fourth. Move it one more time. Is it true scientific notation?
No.
No, but was that my goal right now? Goal was to make the exponents match.
So you have to match the exponent.
0.465. You don't need these last zeros. Behind the decimal, you don't need to finish with those. Times 10 to the fifth. This one never changed. 2.78 times 10 to the fifth. Are our exponents the same?
Yes.
So just like our fractions, we have a common exponent. What do? Subtract what?
The 2.78 minus the.
But what happens to our exponents? What happens to 10 to the power of 5? So I'm going to come down here and put 10 to the power of 5. The multiplication, that's going to stay exactly how it is. Now we can subtract. 2.78 minus 0.465. 5. The key to this, and I don't want anyone making this mistake, make sure your decimals are lined up. You want to subtract tenths from tenths, not tenths from hundreds. Okay? So what has to go above this 5?
A 0.
So really, this is being read as 0 thousandths subtract 5 thousandths. Well, you could, but you're going to end up with negative. So you can do it, but that puts a negative in the middle of our answer. So we're just going to do that. So what is 10 minus 5?
5.
7 minus 6?
1.
7 minus 4?
3.
Bring your decimal straight down. 2 minus nothing? There you go. Two. Ready for another one? There's one thing that could happen, especially when we're adding and subtracting. There's something that can happen. I'm trying to find us the perfect example to give us this. So you ready for the next one? Okay.
Yeah.
I think. Nope. I know the next one is going to be. I'm going to give you another standard number. And it's a lot easier if I just write.
Is this on student?
Nope. Still teacher page. 0.0000321. 4 zeros, 321. After the decimal, 4 zeros, 321. Eileen, what did you say? What?
Are we solving?
Okay, I don't want you just solving it. I want you to take a moment right now. I have 6 different groups. I should hear 6 conversations going on. What is the first thing you will need to do?
You need to turn them into standard form. And then
I'm listening, but
change the decimals. The exponent. And then you would subtract it. But that's we were moving it this way the whole time. The way no, that's a negative. I know, but we've been moving it.
Oh, what have
I think I got it.
Positives.
No, yeah. So now we have to move it the other way.
That's what she's trying to say.
Oh, because the decimal and this decimal is the end of and this decimal is the beginning.
All right, so what's the first thing you guys have to do? Now we have some discrepancies on how to do it maybe, but what's the first thing you have to do? Kiersey? Is it going to be a true scientific notation?
No, you're going to make the exponents the same.
So you're going to go through this process of making it scientific, but make sure you get the same exponents. So which way do we have to move this decimal?
To the right.
Why to the right?
No, negative.
Because it's negative. It's a decimal. We're trying to make a -7. So we move to the right. How many times?
7.
There's actually 2 ways to solve this. I'll go this way first. You do understand it. It's a great method. So now we have 321 times 10 to the -7, all minus 4 9/10 times 10 to the -7. Discuss. What's your next step?
But now you put
Or you make a decimal. 321 minus 1.4.
maybe.
Yeah, listen to the wording. Okay, so what's the next step? Now what do we have to do? Mariana? Subtract what?
The two decimals. The two numbers, 321 and 4.9.
Okay?
Wait, you didn't match the decimals.
I did that intentionally, see if you guys would pay attention. So 321 minus, where should the decimal go then?
The decimal at the end. And then we can just add a 0.
Decimals line up. And so you can show that 0 at the end. So when we do this, what's 10 minus 9? 10 minus 4?
6.
Then your 1 and your 3 come down. Times 10 to the negative 7. Are we done?
Yeah. I mean, that's what.
Is that scientific notation?
Yes.
Oh, parentheses. This was science. Parentheses, that's not going to change anything. Good idea. But this is scientific notation. Look where the decimal's at.
Oh, we have to move it so it can be in between 1 and 10.
Exactly. So we have one more step to this. We have to move that decimal. The whole number, the number in front of the decimal, has to be between 1 and 10. So how many times do we have to move it? 1, 2. Is that adding a 2 to this or subtracting a 2? Adding. When you move the decimal to the left, you are going to add 2. It is now 3 decimal 1 6 1 times 10. What's negative 7 plus 2?
Negative
5.
Negative 5.
This makes much more sense.
Okay? I'm going to show you a slightly different method. If you guys like the way this one worked out, great, use it. I'm going to show you slightly different. I'm going to change it right here. Oh no, it's not a horrible, horrible thing, I promise you. It kind of eliminates it takes, okay. You know how when you multiply fractions, you can either simplify at the very end or you can simplify right there in the middle?
Yeah.
You can either adjust the decimals here at the end or adjust it in the middle. Okay? So right here, hold on, I gotta adjust for gauge. There we go. Right here, I'm gonna use the exact same numbers. Okay? But this was negative 7. Did I have to go negative 7 to make this a scientific? No, I could have erased these two and had it as 3 decimal 21 times 10 to the negative 5th, right? Which one's larger, negative 5 or negative 7?
Negative 5.
Negative 5. That means I could have taken this negative 7 and moved it how many times? Twice. Which way would have gone?
That way.
If I am going to add a 2 here,
To the right.
I'm adding 2. So is it moving to the right or to the left?
To the right.
I added 2 here. Did it move to the right or the left? Move to the left. 1, 2. So it would have been 0 decimal 0 4 9 times 10 to the negative 5th. Common exponents, right?
Yeah.
Some of you are looking at me weird. I guarantee a lot of you guys are probably just going to use this. That's fine. It gets you the right answer. I just found a different common exponent. Watch out, you're blocking. Gauge.
sorry.
Okay? It's going to go through the same process. I just found myself a different exponent. It still works. Because now you have 3 decimal 21 minus 0 decimal 049, right?
Yeah.
4 is under the 1. There we go. It's going to subtract the same way. The difference is the decimal's over here. So just like our fractions, the only difference between this way and this one is when you move the decimal. Am I going to care which way you go?
No.
Not at all. As long as your final answer ends up correct, I am not going to care. Any questions? Yes, Kirsten. Yeah. There's some adding, there's some subtracting. So are you talking about like this part right here? Yeah, sometimes you will add where it becomes more than a whole number. Well, not more than a whole number, more than 10. Well, this answer right here, after you add, will be more than 10. That's fine. You can adjust it. It's the same process happens. Literally, the only difference between adding and subtracting is this one right here. Do you add or do you subtract? Okay. You guys ready for some practice?
Yeah.
Okay. What I want you guys to do then is I want you to go get your books.
Which one?
Hard book. If it's in your locker, go get one from there or get your Chromebook book out. Chromebook book. You have the book access on your Chromebook book.
Yes.
Running a business is hard, Miss Lobmeyer.
Huh?
Running a business is hard.
What page?
I'm trying to get these orders.
There you go. Page 162. When you turn to page 162, right above the guided practice, yes, this one's all on your student page. Right above the green line that says guided practice, you have a got it for A, for B, for C, and for D. So you have 2 adding and 2 subtracting. You see that nice green line close to the bottom of the page?
Above it.
Right above that is the practice problems I want you to do.
Okay.
Do you have to work by yourself?
No.
What would I prefer?
We work together.
Together. I'd prefer if you work together. And this is going to sound really weird, but Gage, if you're watching this, email me your answers.
I'm pretty sure you just gotta have